Hello, and welcome to another brief video lesson on CCD imaging, Earth's atmosphere. While creating some beautiful effects, the Earth's atmosphere is severely limiting from an astronomical imaging perspective. This lesson will outline some of these problem areas that have to be considered. We have other related lessons on extinction, seeing, and air mass that can also be consulted as well. While we live down here on the surface of the Earth, we have to view a stellar object out here all the way through these varying layers of the atmosphere: the exosphere, the thermosphere, the mesosphere, stratosphere, and the troposphere. Throughout the imaging through the Earth's atmosphere, a variety of effects can happen to our images, and we'll see examples of some of those here. Earth's atmosphere is beneficial to us as it provides beautiful vistas and shields us from the harmful DNA-destroying things like X-rays and ultraviolet electromagnetic radiation, and cosmic rays. For ground-based astronomers, these benefits create problems we have to deal with: clouds, light pollution and sky glow, electromagnetic limitations, turbulent atmosphere, and atmospheric extinction. What is extinction? The impact of the Earth's atmosphere can cause an effect known as extinction. We highlight this also in our video series on extinction as well, if you'd like to review that for further reference. This is, though, the dimming of a star's light caused by passing through the atmosphere. Note, there is also interstellar extinction that will be mentioned later. The effect is expressed in units of magnitudes that increase as a viewed object is further from the zenith, straight overhead, and closer to the horizon. Extinction is not the same for all colors. It tends to scatter blue light more than red because the particles in the atmosphere are about the same size as the wavelength in the blue light, and those are getting deflected and absorbed, if you will, but the red tends to come through. So an example here is this beautiful sunset shot, but this is an example of being low in the horizon and having the Earth's atmosphere scatter out the blue, and we get the red light predominantly. Light pollution and sky glow. The brightening of the night sky caused by streetlights and other man-made sources has a very disruptive effect on the natural cycles and inhibits the observations of our stars and planets. When you look here at the Los Angeles basin, there are many stars that are visible, but you cannot see through all of the light pollution provided by man-made objects to see those stars. In this image here, when you do bias, flat, dark subtraction to your image, you can overcome some of these and get an image like this that looks a little more representative of the sky at night. This is another effect of the before image. When you're looking through the atmosphere, you can faintly make out the Milky Way right here, but after applying some flat fielding effects, you can then bring out the night sky and get rid of some of that. Not always all of it, but some of it. We have electromagnetic limitations. The Earth's atmosphere is only transparent to certain forms of light. Radio waves can come all the way to the surface. Most infrared radiation is blocked with only a little bit passing through. All visible light comes through, and very little UV radiation comes through as well. X-rays and gamma rays, totally off limits because the atmosphere blocks those. That's healthy for us as human beings, but sometimes not so good when we're trying to image. And that's why space-based telescopes can really focus on X-rays and gamma rays as well as UV light. So not all light band passes, not all electromagnetic radiation can make it through the Earth's atmosphere. The atmospheric extinction, we have what we call atmospheric. I want to differ from interstellar because this is the Earth's atmosphere that is shading out some of the lights. We talked about that in a previous slide. Here in this image on the right, we have an example of interstellar extinction, not related to the Earth, but it's a good example of what happens. You can see the star field here, but then this cloud of gas and dust called a Bok globule, it's a B-O-K, is taking away the bluer light, and it's allowing us to turn everything red. You can measure this by knowing the spectra of these stars and understanding the visual effect that's happened due to the dust, but know that it is there and that's what it's causing. Our atmosphere causes a very similar type thing to occur. On Earth, we look at a star at the zenith, and what we're viewing through is 1 times the air mass, which is 1 times all of those different levels of of atmospheric extinction that has popped up. Now, as a star starts to come closer to the horizon, we have to look from this same position, a much longer path through the atmosphere, and that starts to eliminate some of our shorter band passes of light, such as blue, and turns things more red and more distorted. An example, sometimes when you see a moon pop up, the moon rises at night and it's red, that's an effect of the atmospheric extinction. It's scattering off the other light, but as it gets higher, that redness goes away and it's more typical of the moon that we see. We have turbulent atmospheres. When starlight enters the Earth's atmosphere, a photon's path can be altered in a couple of ways. It can scatter the light rays when photons bounce off particles. It can refract light rays. So variations in air pressure and temperature cause the bending or the refraction of this light. Varying temps and pressure cause this as well. So significant changes in humidity, smoke, haze, dust, and other sources can impact atmospheric extinction. Limiting atmospheric effects. So some of the factors discussed above can be mitigated by astronomers. So in the case of clouds, we wait till the cloud moves. Light pollution and sky glow. We can use differential photometry, filters, post-processing, standard stars, or go to the desert, go somewhere dark and do your imaging. Electromagnetic limitations, high up on a mountaintop or space-based telescopes. Turbulent atmosphere, image on different nights, or increase the binning, which allows you to minimize some of those turbulent impacts on your images. Atmospheric extinction, view it lower air masses when you have the star more relatively overhead. In summary, this lesson has provided an outline of some of the considerations for how the Earth's atmosphere impacts astronomical imaging and science. Some of these can be mitigated from the Earth's surface, while others cannot, such as gamma rays. For more the effects on seeing an air mass, please consult those lessons provided for you. Thank you for your time, and look forward to seeing you on a future brief video lesson.